Hello, welcome everybody. Here is your 2019 course description from the AP Calculus BC course description. This is FRQ number 1. So let's start by taking a look at this one here. Move this guy over here a little bit here. On a certain weekday, the rate at which vehicles cross a bridge is modeled by the differential function R. R of t is measured in vehicles per hour, and t is the number of hours since 7. R of t is given in the table above here. So vehicles per hour, okay. Part A, use the data in the table to approximate R prime of 5. Well, this is R, so you can approximate R prime. This is almost always the first part of a FRQ table question like this, estimating a derivative from a table. So 5 is between 4 and 6 here. It's perfectly centered, so you're going to want to use these numbers here. And that's just basically a derivative. Derivative is slope of the tangent line, so you're estimating it by just doing slope right here. Your point values are associated for this one by your first point is going to be given by the approximation using the values from the table. Now this is a calculator problem, so either one of these answers are acceptable. You'll see a little bit later why it's actually probably pretty good to put the negative 216 in here. And then the other part is explain the meaning of R prime of 5 using correct units. So the units, let's start there. Units are vehicles per hour, or vehicles per hour squared. Remember, whenever you're doing a problem like this, and you're trying to estimate a derivative, which is a slope, you take the y values, units, vehicles per hour, and divide them for slope by the x-axis, in this case, the t-axis units, hours. So vehicles per hour, or per hour squared. Now the interpretation again is you need to start with this at 5 hours or have that somewhere here. You're not evaluating R prime of t, so if you leave this off, you're just coming up with a formula, not a specific at 5 here. So you need to have this at 5, and if you said 12 p.m. because of the way 7 o'clock is 0, that's perfectly fine too. But then here's the key also with this interpretation. You need the at 5, and it's the rate at which vehicles cross the bridge is decreasing at a rate of 216 vehicles per hour. So if you just said like was going down and you didn't have this first rate in here, as long as you said it's decreasing at a rate of with the proper units, they give that to you. But that's your second point. Part B. Part B says use a midpoint sum of 3 subintervals of equal length, 3 subintervals, indicating the data table to approximate this integral Riemann sum. So you want 3 subintervals. So anytime I do a table problem, I'm asked for a left, right, or midpoint Riemann sum or trapezoidal, I like to draw a picture. Some of you always comment to me that you make little mistakes along the way and you need to clean those up. A way to clean up a table problem is to draw a picture. So I just really quickly, because time is of the essence here, you don't want to actually put values in here and make everything detailed. I just put the dots going up, down again. Now 3 subintervals means I'm going to have like this alley here, which would be interval number 1. This alley here, which would be interval number 2, and this alley here, which is interval number 3. You want 3 rectangles. So how do you make 3 rectangles? Well, in this area here, if it's an R-ram, you're going to go from the right side over and down. If it's an L-ram, you go from the left side over and down. But a midpoint goes from the middle value over and down. So this is your rectangle number 1. Same thing with rectangle number 2. It goes from the middle. And anytime you're doing an S for an M-ram, you're always going to notice that the middle is going to be very clearly picked right off the table. You'll never have to average anything like that on a problem like this. And here's your third one. So now the other part is what's the length. I'm going to actually put this in purple so you can see it. What is the length here or the width of each of these rectangles? Now remember, you're starting at 0. This is a 2, but this is a 4. So your actual width of every one of these, because they're equally spaced, doesn't always happen this way, is 4. So you could have done 4 times R2, 4 times R6, 4 times r of 10, or you could have factored out the 4 only because these are equally spaced intervals. So the midpoint sum setup, the first point, is either this part right here, or if you kind of skipped that and went right to numbers, they're okay with that. Since it is a calculator problem, it's probably a good idea to just plug this into your calculator and get 34,596, but they will take unsimplified versions. So actually, if you just put this here in your first step right there, they'll probably give you both points pretty easy. Midpoint sum. Then when you get to part C, on a certain weekend day, this is a weekday, the rate at which vehicles cross a bridge is modeled by this H from 0 to 17. H is measured in vehicles per hour and T is it. So it's the same thing. Instead of having a table, you have a function. According to this model, what is the average number of vehicles crossing the bridge per hour? Well, this is a function of vehicles per hour. You want the average vehicles per hour. So basically you're staying at the same level or the same derivative, however you want to think of that. When you're doing that, it's an average value theorem. It's not rate. If they wanted the average vehicles per hour, then you would be doing a slope calculation. H of 12 minus H of 0 over 12 minus 0. But since this is staying at the same level, same units, you're doing your average value. The first point, definite integral. That just means this blue box part. A lot of students forget the divided by 12 or multiply by 1/12. So if you did forget that, you will get this point, but not the answer. And then the answer is 2452. How would I do this one? Well, I'd take this H and I'd substitute it into my calculator for F1 of X. And then I would just manually calculate a definite interval on my calculator. It goes very fast. If you kind of look ahead to part C, it makes a lot of sense to put this into your graphing portion of F1. And then you can just reference F1 of X when you're doing that integral on your calculator. All right, so those are your 2 points. The last part, part D, a little bit trickier for this part. So part D says, from 12 to 17, the local linear approximation function H given in part C, so that other one you should have entered in your calculator from the last part, is a better model for the rate that vehicles cross a bridge when you get from 12 to 17. Use L of T, this local linear approximation, to find a time between 12 and 17 at which the rate of vehicles crossing the bridge is 2,000. Okay, so what's the plan here? What does local linear approximation mean? Basically, it means tangent line. A lot of these things are tangent line. So what kind of questions will you ask for tangent line? Find an equation of the tangent line. That's a simple one. Find a local linear approximation. Find a linearization. Euler's method. Euler's method is using a tangent line with multiple steps. All of those things basically is your point slope form. So this is your L of T point slope form. So you take your initial amount. Remember, you're trying to take the linear approximation at 12. So your ordered pair is 12, comma, something. And this something is going to be, using H. So you'd be finding this as H of 12 here for that point. So how do you find H of 12? Well, you go back to the last part. If you already had this in your calculator, it's really easy. You get trace, you get 12, you get an answer. That's going to be 2596. How do you take the derivative? Well, if you have your H substituted into your calculator, it's really easy. You take the derivative on your calculator at a point. So d dx, if you don't have the derivative typed in, or the function typed in, you'll have to type it all in. But if you do, you can just take the derivative of f1 of x, and then you're going to have to use that such that button, which is a little vertical bar. I think it's above the equal sign. And then x equals, and this is going to be at 12. X equals 12. A little sloppy here, so I'm drawing with my mouse. But just calculate that. It goes very quickly. That gives you negative 216. So now the question is, how do you allocate points? The first point, is given from finding the slope. So if you have this negative 216 on your paper anywhere, you get a point. And then knowing that you have to use this L of t equals 2000, your L of t is this. If you set it equal to 2000, that tangent line, that's perfectly okay. You can plug 2000 in here. Here is all the numbers substituted in. Lots of ways to get this second point. And then the answer is that third point. The answer point is going to be 14.759. Now the question is, how do you get that? Well, the easiest way to do it is to type this guy here into, since you already have F1, I'd probably type this guy into F2. And then I probably type this guy into F3. And then either deselect F1 if you want to, or try to ignore it, but you're basically finding an intersection. Here's ultimately what it looks like. So this is a line with a downward slope going downward like that. And then at y equals 2000 is horizontal line, so you're trying to find that intersection. That intersection happens at this point, 14.759. So I calculated intersection using my calculator. That's it. Those are your 9 points for this table question. A little trickier and kind of unique on part D here, but the other parts were pretty traditional. Thanks for coming, everybody. And grade accordingly.